Okay, Chapter 9, Day 4 video. What we're going to look at today is what are the special angles for trig functions. There's some special angles that we're going to learn about that hold true throughout the rest of this unit, throughout pre-calc, throughout calc. These are the ones that you're going to have to know like the back of your hand. Now, earlier this year we did a problem with an isosceles right triangle. And we learned that for these two sides, if they're the same, because it's isosceles, so let's say this is the congruent sides, okay? A squared plus b squared equals c squared. This side worked out to be 7 radical 2. I'm not going to do that whole math again. But if you do Pythagorean theorem, this side works out to be 7 radical 2. Now, if this number is a 5 and this number is a 5, this number is 5 radical 2. It's just how it works out doing Pythagorean theorem. So if I want the sine of a 45-degree angle, here's a 45-degree angle, it would be 7 over 7 radical 2. Okay? Well, if I pick, let me just move this over here. Hang on. 7 over 7 radical 2. Again, I don't like to leave the radical 2 on the bottom. So I'm going to multiply by radical 2 over radical 2. The 7's reduce. Radical 2 times radical 2 is just 2. And we get square root of 2 over 2. Okay? Cosine of 45. That's adjacent over hypotenuse. It's going to be the same thing. 7 over 7 radical 2 reduces down to radical 2 over 2. And the tangent, which is opposite over adjacent, or the sine over the cosine, 7 over 7 is 1. And so what we can tell is for any isosceles right triangle, the sine of the angle, which is 45 degrees, radical 2 over 2, and then the tangent of theta is going to be 1. So for any isosceles right triangle, it's going to have a 45-degree angle. So the sine of 45 degrees will always be square root of 2 over 2. The cosine of 45 will always be square root of 2 over 2. The tangent will always be 1. Okay? Let's take a look at an equilateral triangle. I'm just helping develop their special. This is one of our special angles, 45 degrees. Okay? Equilateral triangle. Well, in an equilateral triangle, here's one that I made up, sides 8. I can drop an altitude perpendicular to the base. Okay? What I'm going to do is I'm going to redraw this little triangle right here. Okay? 8 and 4. If we do Pythagorean theorem using the 8 and the 4, and this side, a squared plus 4 squared is 8 squared, Pythagorean theorem tells us that the missing side is 4 radical 3. Just simplifying radical 48. So now, again, the sine of 60 degrees. Again, if I pull out this little triangle, right, this is a 60-degree angle. Sine is opposite over hypotenuse. 4 radical 3 over 8. Well, I have to reduce that. The 4 can go in the 8 twice, leaving me radical 3 over 2. So the sine of a 60-degree angle is radical 3 over 2. Cosine, adjacent over hypotenuse, 4 over 8, that reduces down to a half. Tangent, which is 4 radical 3 of 60 degrees. 4 radical 3 opposite over 4. So 4 radical 3 over 4. The 4's reduced, leaving me just radical 3. And so the sine of 60, square root of 3 over 2. Cosine of 60 is a half. Tangent of 60, square root of 3. That's true no matter how I draw this triangle, how big or how small, that relationship will always hold true. Sine of 30 degrees, well, if this is the 30 degrees, the opposite over hypotenuse, 4 over 8, which reduces down to a half. Cosine of 30. cosine of 30. This is adjacent over hypotenuse. That's 4 radical 3 over 8. Okay? Same thing I had over here, reduced down to radical 3 over 2. And the tangent of 30. The tangent, opposite over hypotenuse. 4 over 4 radical 3. The 4's reduce, right? This is 4 over 4 radical 3. Those 4's reduce. Okay? Leaving me 1 over the radical 3. But I do not like radicals on the bottom. We want to rationalize that. We're going to multiply by radical 3 over radical 3. My answer is radical 3 over 3. Square root of 3 over 3. So again, for any 30-degree angle, the sine of a 30-degree angle is going to be a half. The cosine of 30 is radical 3 over 2. The tangent of 30 will always be radical 3 over 3. I'm just showing you how we could create those angles using equilateral and isosceles triangles. So, again, what are the special angles for trig functions? Here they are. The special angles are 30, 45, and 60. We just had those with those triangles. Along with my, what we call the quadrantal angles, when I'm on 0, 90, 180, 270, 360, when I'm on the quadrants. Okay, when I'm on 0, 90, 180, 270, and back again at 360. Okay, so we have a little chart we can fill out. All right, for 0 degrees, the sine, which is the y value, is 0. The cosine is 1. Tangent, sine over cos, or y over x. 0 divided by 1 is 0. 30 degrees, we already did that up above. Those are the ones we had. A half, square root of 3 over 2, square root of 3 over 3. We just, in this problem here. Okay? 45 degrees, we learned that sine was square root of 2 over 2, cosine square root of 2 over 2, tangent is 1. Alright? 60 degrees, we just did it in the previous problem. 90 degrees, okay? Sine is 1, because that's the y value. Cosine is 0, okay? And 1 divided by 0 is undefined, so the tangent is undefined at 90. 180, sine is 0, cosine now is negative 1. 0 divided by anything will be 0. 270, the sine or y value is negative 1. The cosine is 0. And anything divided by 0 is undefined. And 360, back here where we started, the sine is 0, because that's the y value. Cosine is 1. And 0 divided by anything is 0. And this is the special triangles, or special angles, okay? Which is 30, 45, and 60, along with what we call the quadrantal angles. And so, here it is visually. If I draw 30 degrees in quadrant 1, I know the sine is the y value. So, across from the 30 is always a half. And if this is 30, then this is 60. And I remember that because 30 is half of 60. So across from 30 is a half. This is on a unit circle. So this is 1. So then this side is square root of 3 over 2. Because the cosine is square root of 3 over 2. If it's a 60-degree angle, all I did was take this and turn it upright. So now this is the 30. And again, across from the 30 is a half. And across from the 60 is square root of 3 over 2. So the cosine is a half and the sine is square root of 3 over 2. And you can see that right here, sine and cos. If it's a 45-degree angle, triangle, this is also 45. And again, what did we learn? That both the sine and the cosine have values of square root of 2 over 2. And then also the tangent, anything divided by itself is 1. And that's special triangles. And you're just going to have to know these like you know your phone number. Eventually you will get there.